Hello and welcome to another Ginger Mathematician video where I'm going to go through advanced mensuration questions. So this follows on from a video I did last year when I went through all of iGCSE mensuration, and I've had some requests here to do an advanced version of it. So really focusing on mostly paper 4 questions here, and the more advanced skills you need to succeed to get those A and A star grades. Right, let's get started. So question 9 is here, and we have a sector of a circle which is given for us. We're told the radius is 8 and the sector angle is 165 degrees. And generally a paper 4 question, they will start off with some of the slightly easier questions here. And the first thing to do is work out the total perimeter of the sector. Now, what does the perimeter mean here? Well, we need to work out this arc length here. So remember, this is called an arc. But remember we want the perimeter, and the perimeter is the distance around the entire shape. So once we've worked that out, we need to add in this 8 centimeters, and remember this is also 8 centimeters as well. This is also a radius. So how do we do this? Well, to work out the arc, we need to remember this formula. It is not given to you on the formula sheet. So we have the angle, so 165. All divided by a total turn, so that's 360. And then we use the normal formula for the circumference of a circle. So remember, the circumference of a circle is equal to 2 pi r. Again, another formula you need to know. So if we use the formula here, so we've got times 2 times pi, and remember the radius is 8. So that's going to give us our arc. To work out the total perimeter, we're going to take what we've done for the arc. Again, notice I'm leaving the calculating until right at the end here. And then we need to add in the 2 radii. So we've got 8 and 8. So we add in the 16. And that's going to give us our final answer. So let's go over to the calculator and work it out. Okay, so I'm going to use this calculator here. Again, this is generally for the 0607 course, but I'm just using the standard functions. So we're going to type everything in here. So 165 divided by 360 times 2 times pi times 8. Now remember, that is going to give us the arc length, but then we want to add in the 2 radii. So 8 plus 8 is 16. And notice I've left all of this until the very last moment. Now I put this on a float 4. That'll give us enough here in order to get to the right answer. So we get 39.04, which I'm going to write in here. So 39.04. Again, generally I'm going to do this to 1 decimal place here, so this will be 39.0 for our 3 marks. So starting off kind of nicely, it does get harder towards the end of the question. Now part B is the surface area of a sphere, so underlining the key information here, is the same as the area of the sector. Now notice this is the area of the sector, not the perimeter anymore, and we need to work out the radius of the sphere. So we're given the formula, so that's very, very useful. This A equals 4 pi r squared. Before we really get started, we want to work out the formula for the area of a sector. Now the area of a sector works a very similar way to the arc. So we take our angle, so we have 165 over 360. But this time we're going to times by the area of the circle formula, and that's equal to pi r squared. So in this case, it's going to be pi times, now our radius here is 8, so that's going to be 8 squared. And we're told that these two things are the same. So in this case, what we've just worked out, so 165 over 360 times pi. Now as I go along, I do like to simplify. 8 squared here is 64. And that's equal to this formula here for the surface area of a sphere. So that's going to be 4 pi r squared. Now, one of the reasons to write this out so formally is that we can actually do some very nice cancellation. So first of all, we have a pi on both sides, so I can cancel the pi. Notice we've got factors of 4 on both sides. So how many 4s go into 4? Well, just 1. How many 4s go into 64? Well, that's 16. Again, 16 times 4 is 64. And notice by doing this process, I'm really simplifying this down very quickly. So we get 165 over 360 multiplied by 16. And now all I'm left with on the right-hand side, which is fantastic, is r squared. And so to work out the radius here, what's the opposite of squaring? Well, that's going to be square rooting on both sides. So I just square root the left-hand side, and that's going to be equal to, well, these two things cancel, opposite operations, equal to r. So notice I haven't reached for my calculator any parts in that calculation, and I always try and leave it until the end. That's a really cool tip for these AA star style questions. So let's go to the calculator and see what it is. So we're going to have a square root, and we've got a fraction here. 165. I mean, you could do some simplifying to make this easier to type into your calculator. And then we're going to multiply that by 16. Press enter. And then we get our answer of 2.708. So let's write that down. 2.708. And generally, I'm going to be rounding here to 1 or 2 decimal places. In this case, I'll round to 2.71 centimeters for our 4 marks here. So far, so reasonably normal. This is maybe a little bit trickier with the algebra. Notice part C here is when it gets quite difficult. Okay, and on to question C, which is where it gets slightly trickier. So we're going to take that sector that we've seen before, and we're going to make a cone from it by joining OA to OB. So let's identify exactly the comparisons between the sector and the cone that we have in front of us. Well, the first thing to consider here, if I do this in blue, is that this side here, the OA side, so again, you can always use these to help you visualize. That's going to be the radius, which was 8 from the sector. Again, I'm just using that directly from the letters here, O and A. And more importantly for the question in front of us, let's do this in green. So what we're going to do now is that the circumference, so this green part of the cone, that's going to correspond to the arc of the sector, which we actually worked out in the very first part of the question. So let's then do these two parts of the question. So first of all, we want to work out the radius of this cone. Well, remember the circumference of a circle, that's going to be equal to 2 pi r, and that's going to be equal to the sector that we looked at before. So remember, we had 165 over 360 times 2 times pi times 8. So that came from part A of the question. Now we can do lots of cancelling here, which is amazing. So we can cancel out the pi's from both sides. We can also cancel the 2's from both sides. And then R then just drops out to be 165 over 360 times 8. Now again, you could do this without a calculator, but let's go to my calculator and work this out. So all we do is just type in 165 over 360 times 8, giving us the exact answer of 11 over 3, but can be written as a decimal as 3.67. So we're going to pop that across. See, this 11 over 3 is going to be important a little bit later on, but for this question, we're going to write this to 2 decimal places, so 3.67, like so. And on to part D, where we need to find the volume of the cone. And usual with these 0580 question here, they give you the formula you need to use. Now, if we look at the formula, the thing that we're missing here, the thing that we don't know, is the height. Once we know that, because we have the radius, remember the radius is what we just worked out as 11 over 3, then we can just plug it into the formula. Now notice here we have a right angled triangle. So if I just draw this out separately, so we can really see what's going on, our radius, which is the one at the bottom here, is equal to 11 over 3. We know the length of the radius, this was 8 from the sector in part A, so this is equal to 8, and this is h here, which we don't know. Now again, we can use Pythagoras for this. Again, for the more advanced skills, so looking at the A grades, for example, I highly recommend you get in the habit when you use Pythagoras of just writing in one clean calculation. So h is equal to 8 squared, remember this is the hypotenuse here, minus the smaller side squared, so 11 over 3 squared. Now notice I'm not rushing to my calculator here to actually work this out as a decimal, because I'm going to need it in the last calculation I've underlined here, but I've shown my working to guarantee 2 of the method marks. Now to work out the volume, all I'm going to do is substitute in everything that we have. So we have 1/3 times pi. Now the radius of this particular cone we already worked out, so 11 over 3. And then the height, which we've just worked out as an expression here, so 8 squared minus 11 over 3 squared. So notice I haven't done anything on my calculator until I've got to this very last point of the calculation to avoid those rounding errors. So let's go to the calculator and work this out. Okay, so let's just pop this in carefully. So we have 1/3 first of all. It's all about it being accurate here. Then we've got pi. And let's just check. So we've got 11 over 3. So notice as I'm going through this, I am checking very carefully to make sure I'm writing this in. And then we've got our square root. So control square root. Again, 8 squared minus, making sure we write this in nice and carefully. And one of the benefits of using this calculator, as you're going to see in a moment, is if you want to put brackets in afterwards, say I forget them. So one of the benefits of this, you can just put bracket there and it will automatically put brackets in. However, sometimes it's not so clever and you have to help it put brackets around the right part because we want all that squared. And notice I'd always do a double check at this point. Look at this calculation. Look at what I have. Is it the same? Yes, it is. We press the enter button and we get to our final answer here of 27.3014. Now, if this happens in the exam and you get the incorrect answer, then you have to go back and go, okay, what mistake did I make here? Well, I forgot to square the 11 over 3. So one thing to do here is actually check the estimating part of this. If you imagine you take the area of the base, which if we approximate this, if we know that's 3.67, again, area is pi r squared. So again, I'm doing an estimating approach here. This is roughly 3. This is also roughly 3. And then this gives me 27 just for the base alone. So getting the answer that I did, because I'm going to times it by height, that doesn't sound reasonable. So if that's happening to you, then you need to go through the formula and go, okay, where did I make the mistake? And the mistake here was forgetting to square the 11 over 3. So let's go back to the calculator and pop that back in. Okay, so what I'm going to do is just going to copy and paste this. I mean, I could have edited this out of the video, but I think it's good for yourself to actually see, okay, I'm not convinced the answer is correct. It doesn't seem correct from the other things that I know about this problem. Go back through, check and see, okay, that's where the mistake was made. So if I put this in, now I get to the correct answer of 100.1. So it's going to pop that in. Okay, so I'm going to keep this to one decimal place here. So we're going to put this in as 100.1 cubic centimeters. Now you can check the answers here. You can see the rounding, as long as you round something sensible, you are going to get all the answers there. Notice you get 3 method marks for writing the exact calculation that I did. And those are the answers there for question 9A and 9B. But it's really important as you go through a problem, you don't switch off that brain, you don't just rely on the formula. You think, okay, is that giving me a sensible answer? No, it isn't. What could be missing from it? Right, on to question 8. If you're liking this content and my thought process as I go through this, then please do think about liking and subscribing. It really helps me know exactly which videos are the most helpful to you out of the videos published recently. Okay, on to question 8 here. So we've got triangle ABC is mathematically similar. As soon as you see that phrase, you need to be thinking scale factors. And the area of triangle ABC, so the smaller one here, is 16 square centimeters, and we need to work out the area of triangle PQR. Standard procedure here. So first of all, we want to work out the scale factor. Now the way we do this, generally I go from big to small. So I'm going to do 12 divided by 8. That's going to be equal to 3 over 2. Cancel it down. Then we want to work with areas here. So then we want to work out the area scale factor. That's going to be the scale factor we just worked out here, squared. And 3 squared is 9, 2 squared is 4. And then finally, to work out the area of PQR. This is a pretty standard similarity question, but do make sure you're happy with this idea of scale factors. Then we take the 16, and because we're going from smaller to bigger here, we're going to multiply by our scale factor. So we're going to multiply by 9 over 4. Now in this case, we don't really need a calculator. We've got some cancelling. 4s into 4s go 1. 4s into 16 go 4. 4 times 9 is 36. So even though this is a calculator question, don't feel like you always have to rush to your calculator. If you can work it out with non-calculator means, it will save you time in the exam. Right, on to the next part here. So the triangles are the cross sections of prisms. So that's important to know here, which are also mathematically similar. So same idea. The volume of the smaller prism is equal to 320 cubic centimeters. Calculate the length of the larger prism. Okay, so they're both in the same proportion. We worked out the area scale factor before. So now we need to work out the volume scale factor. And the way that we do this is we take the standard scale factor, so 3 over 2, and then we're going to cube it. So if we do that process, well, 3 times 3 is 9, 9 times 3 is 27. And then 2 times 2 is 4, 4 times 2 is 8. So our volume scale factor is going to be 27 over 8. And this doesn't actually help us work out the length straight away, so we'll come back to that. But we can certainly work out the volume of the larger prism. So volume of larger prism. Well, that's going to be, got 12 here. So volume of large prism is going to be 320 times 27 over 8. Remember, going from smaller to larger here. Now, one thing to be aware of, got a bit of cancelling here. So 8s into 8 go 1. 8s into 32 go 4. So this becomes 40. And so we get the calculation of 40 times 27. Now, I'm just going to do this on my calculator here. It's a quick calculation. This is equal to 1080. Now, this is not the answer, but we can work out now the length of the prism. So the length of this prism is going to be the volume divided by the area. Notice we've worked out both these things now. So the volume was 1080. We worked out the area of the triangle, which was 36. You pop that in, and then we just do 1080 divided by 36. Again, I'm just going to use a calculator for this, and that gives me then the answer of 30. I'm using the idea here that a prism, the volume of it, volume of prism equals area of cross section, CS, times length. So if we want to work out the length, then the length, just by a quick rearrangement of that formula, is going to be the volume of the prism divided by the area of the cross section. So I'm exploiting this formula to then work out the answer quite quickly and quite efficiently here as 30, like so. Right, on to then a bit more algebra based, this one. So now we've got a cylinder with the radius of 6 centimeters. Interestingly, they don't give you the formula for a cylinder, but they do for the sphere, which is kind of confusing. We're going to work with volume here. So the volume of a cylinder, this is one you do need to know, is equal to the base, the area of the base, which is pi r squared, times the height. So we're going to use that a bit later on. and we're told that this cylinder has the same volume, so it's going to be equal to, so we'll come back to that, as a sphere with radius 4.5 centimeters. Notice the units are the same, that's always something to check, centimeters, centimeters. And we want to work out the height. So the volume of the cylinder, I've got the formula here. So all we know here is that the radius is 6, so we do pi times 6 squared times h. And that's going to be equal to the volume of the sphere, which is going to be 4/3 times pi times 4.5 cubed. Okay, so at this stage, again, we see what can cancel and what can be removed. So the pi's cancel, which is very helpful. So 6 squared is 36, so we get 36h equals 4/3 times 4.5 cubed. Again, not rushing to my calculator here, just working through the algebra to see what I can simplify here. Well, I've almost got h now. All I need to do is the opposite of timesing by 36. That's dividing by 36 on both sides. This cancels, leaving us with h equals 4/3 times 4.5 cubed all over 36. Once I've got it into this form, then I can go to my calculator and work it out. Okay, so we want open brackets, 4/3 like so. Let's check calculation of putting in 4.5 cubed, 5 to the power of 3 divided by 36. Press enter, and we get a precise answer here of 3.375. Perfect. So h equals 3.375. Since it is an exact value, I'm just going to leave it as that. So 3.375. Again, you could round that to 3.38 if you so wished. So that's nice. Always a good sign when these kind of questions you get a reasonable looking number here. Now on to part C. So a solid metal cube of side 20 centimeters is melted down into 40 solid spheres, each of radius r centimeters, and we need to work out the value of r. So the first thing is the volume of the cube. Don't forget how to work that out. That's just going to be equal to 20 cubed. So it does 20 times 20 times 20. That's going to give you 8,000 cubic centimeters. And it's been melted into 40 solid spheres. So this 8,000 needs to be equal to 40 lots of this formula here. So 4/3 pi r cubed. Again, no rushing to the calculator here. I'm just going to try and remove as much as I can. The first thing that comes to mind here is dividing by 40 on both sides. So 8,000 divided by 40, that's going to give me 200. Again, you can always check backwards to make sure you've got that. This cancels here, leaving me with 4/3 pi r cubed. Again, no rushing to the calculator here. All I'm going to do is get r on its own. So the first step, what's the opposite of timesing by 4/3 pi? Well, dividing by 4/3 pi. We do that to both sides, giving us 200 over 4/3 pi. Again, this cancels, leaving us just with r cubed. Again, what's the opposite of cubing something here? Well, we want to cube root. So again, I'm not reaching for the calculator until I've got this expression here, so I can get the most accurate answer possible. That's where most of those marks you lose, because you're not keeping the precise value all the way through the calculation. Now we've got this, we can just put this into our calculator. Okay, so we want a cube root here. And let's see what we need. So we need a fraction for the 200. We need another fraction here. So 4 over 3 times pi. Okay, I think I'm happy with that. Press the enter button. Yep, we get 3.627. 0.6278. Again, I'm going to round this now to 3 significant figures, so that's going to be 3.63. Again, crucial with these questions, make sure you're writing your working through. Don't reach that calculator too soon. I'm going to keep saying this again and again in this video. And now we're going to go into a more algebraic approach here. So a solid cylinder has radius x and the height of 7x over 2 centimeters. The surface area of a sphere, which we're given here, 4 pi r squared, with radius r, so capital R in this case, is equal to the total surface area of the cylinder. That's sneaky, total surface area. Now the formula for that is a little bit more complicated. It's going to be equal to 2 pi rh, so that's the curved surface area, plus the circle top and bottom. So that's going to be 2 pi r squared. So what we need to do is we're going to take this formula, because we want it in terms of the big R, so in terms of the sphere's radius. So this means that 4 pi r squared, so just like this, is equal to, now let's go through this, the radius is equal to x, so we get 2 pi x, and the height is equal to 7x over 2 plus 2 pi r squared. Well, that's just going to be x squared, like so. Okay, so let's work through the algebra here. Again, the first thing to do here is just look for things to cancel. So the first thing that comes to mind here, I'm going to do a little bit of factorization here. I'm going to cancel these. No, I'm not going to cancel those. They need to stay exactly where they are. Let's take a factor of 2 pi out. So if I take 2 pi out and simplify, get 7x squared over 2 plus x squared. The reason I'm cancelling that out here is that this pi cancels, this 2 cancels 2 here. So we get 2r squared is equal to, well, we can actually add these together, because remember x squared here is the same as 2x squared over 2. So you unsimplify it. So if we add those together, well, 7x squared over 2 plus 2x squared over 2 is 9x squared over 2. And at this point, these 2's cancel, which is very helpful. No, don't cancel, sorry. So you get 2 here, so we just times by 2 on both sides. That gives us then 4r squared equals 9x squared. And we want r on its own, so the opposite of timesing by 4 is dividing by 4 on both sides. This cancels, we get r squared equals 9 over 4. This is always a good sign because 9 and 4 are square numbers, so that's a good sign. And then the final step here, we need to square root both sides. If we do that, that cancels, we get r on its own. Now square root of 9 is 3, square root of 4 is 2, and square root of x squared is just x. So we get to our answer there. So r is equal to 3 over 2x. So these are really tricky questions, really at the top end, this AA star part of the course. And the key thing is just to keep your head, work through the algebra. They generally do design these kind of questions, so things do simplify. And so if you're getting to an answer like this, you're pretty confident that you've got to the right answer. So you can check the mark scheme here, so you can see where you picked up all these marks. If you can really do well on these really difficult paper 4 mensuration questions, we have 2, 5, 8, 11, 14 marks worth here, and that could be yours if you practice these kinds of skills. Okay, on to this question 6, a nice mixture of skills in this question. So we've got a triangle ABC, have point G inside and given some lengths that come off that, and then we're given these two angles CAB at 42 and angle ACG at 54. And the first thing that we need to do here is work out the value of x. So I look at this problem, and the first thing that I notice here is I've actually got 3 sides, which is a little bit unusual really. So I've got 5.3, 6.9, and then 11 in this particular triangle. As soon as I've got 3 sides in a triangle and I want to find an angle, this calls for the cosine rule. And more specifically, I want the angle cosine rule. So the cosine of C is equal to a squared plus b squared minus c squared, all over 2AB. Now, if you need to go through this in more detail, then do check out the video above where I spend 1 hour going through trigonometry questions just like this. Now, the key thing is to be able to label those sides. So the angle is here, the side opposite that is small c, and then the other two sides are A and B. It's crucial you label that correctly so we can use the formula correctly. So we then get cosine of c is equal to, well, 5.3 squared plus 11 squared minus 6.9 squared, all divided by, well, A and B, so 2 times 5.3 times 11. And I'm not rushing straight away to the calculator because we want to actually find angle C. So the opposite of cosining is inverse cosine on both sides. If I do this, this cancels, then we can find out angle C, which in this case is x here, and then we want the inverse cosine of this fraction above. So now let's go to that calculator and work it out. Okay, so make sure it says degrees at the top. That's always the first thing to check here. And we want inverse cosine, and we need to set up a fraction here as well. Let's remind ourselves what it looks like. So 5.3 squared, 5.3 squared. Making sure we write in everything here. 11 squared minus, there we are, 6.9 squared. Perfect. And then down below, we've got 2 times. The way I always think of this is the 2 first numbers here. So 5.3 times 11. Press the enter button, and then we get our answer of 29.50. Now I'm going to write that down. 0.50 dot dot dot. And of course, to 1 decimal place here, that's just going to be 29.5 degrees. We are going to need that number a bit later on, so definitely keep that in mind. Now on to part 2 here. They want us to work out the length AC. Now, a nice little trick here is they've used the cosine rule for one question. You're probably going to use sine rule for the next question. But let's just work this out. So let's just call this a letter. Let's call this y. At the moment, we can't use the sine rule because we've got 11 and 42, but we don't have y in opposite angles. So I'm kind of working backwards here. I need to find this angle, and I can do that with the very big triangle ABC. Remember, we now know what x is. It's 29.5000. So the first thing that we need to do here is work out angle B. So angle B, well, that's going to be equal to 180, because angles in a triangle add up to 180, minus, and then we need to add everything else together. So 42 plus 54 plus this new angle we worked out, 29.50 dot dot dot. So let's go to my calculator. Let's get a really accurate answer. So we're going to do 180 minus 42 plus 54. And now this is where you can use this nice function, works on most calculators, answer. So we'll take our answer from before, the 29.5, and this gives us then 54.4965, which I'm going to write down, 54.4965 dot dot dot. Okay, so now I've got that angle. Now I can use the sine rule. Now what is the sine rule? Well, remember, it's A over sine A equals B over sine B. Now we just need to label the sides here. Again, we're going to use a different color because we are labeling it differently. So this y here we're looking for, that's going to be our A. The angled opposite, that's going to be our big A. And then the other two sides that we do know, well, this is going to be small b, and then we'll keep this at big B. So making sure we label them, knowing which one's which, makes it easier to work out. So if we pop this in, we've got y at the top here, we have sine of the angle we just worked out, so sine 54.49 dot dot dot, and that's equal to b, which is 11 over sine 42. Now notice I'm not rushing to my calculator at this point. It's a common theme in this particular video. First of all, I want to get the y on its own here. It's the opposite of dividing by sine 54 point something is timesing by sine 54.49 dot dot dot. on both sides. This cancels, leaving us with what we're going to look for, y, and then we get 11 sine 54.49 dot 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 all over sine 42. Once I've got it in this very nice form, I can use that answer button you saw in the previous step also here as well. Okay, so we're going to type in 11. Actually, let's set up the fraction first. So 11, and now we want sine. This is where we're going to use the answer button, which is so useful last time, and then divided by sine 42. So trig. You can actually type in the letter as well, sine 42. That also works. And then that gives us our answer of 13.38. The most accurate answer here. Can't be any more accurate than this. And again, we always round to one decimal place. So that's going to be 13.4 centimeters to give us our answer. Okay, and now they're moving on to a nice little twist here. I had a request about these kind of depth problems, so I did want to go through one. So water flows at a speed of 20 centimeters per second, that's really important, along this rectangular channel into a lake. The width is 15, the depth is equal to 2.5, and we need the amount of water in litres that flows from the channel into the lake in 1 hour. So the way I would focus on this is that 20 centimeters per second. Well, let's think, how much is that per minute? Well, it's going to be 20 times 60. So if we do 20 times 60, that gives us 1,200. Again, use a calculator. That's going to be then centimeters per minute. And then we want to get to an hour. So what do we do to go from minutes to hours? We times by 60 again. So times that by 60, we then get 72,000 centimeters flowing through per hour. Okay, so we've got that dimension here, 72,000. Remember the dimension of anything rectangular in shape, we're going to times these together. So to work out the amount of water, now we've got it in centimeters per hour. We take that answer, 72,000, times it by 2.5, and then times it by 15. Not quite finished at that point, but that's the key working to do here. So if we times those together, we then get a very big number, so 27 and then 5 zeros. So we've got 2, 1, 2, 3, 4, 5. Now this is in cubic centimeters, because notice we've worked in centimeters so far. We've worked out a volume essentially here, so that's why we're using cubic centimeters. And the conversion you really need to know is that 1 cubic centimeter is equal to 1 milliliter. So using that idea, 1,000 cubic centimeters is equal to 1 liter. So how does that help us in this problem? Because we want it in liters. Well, we take that answer and we're just going to divide by 1,000. Because there are 1,000 cubic centimeters in a litre. If we do that, essentially 3 zeros are going to disappear here, and we get 2,700 as our final answer. I guess the trickiest part about this particular question is making sure you get the units correct here, centimeters per hour, because we want to work it in 1 hour. Notice if it was a question in 2 hours, we'd have to times this by 2, or in 5 hours, we times that by 5. So that's the thing to watch out for here. So you can have a look at the solutions here and look through what you have done here. Again, we've done a nice mixture here of sine rule and cosine rule with this kind of depth question that is also coming up more and more often on these more advanced mensuration questions. Right, and on to the next question here. And this leads on very nicely from a recent video I did here on looking at trigger words. And one of the trigger words I identified here is exterior angle. So as soon as you see this, as soon as you see that, you need to be thinking, 360 divided by the number of sides. And how many sides do we have here? Well, we've got 18 sides. So it's just 360 divided by 18, and that's going to be equal to 20, so 20 degrees. Again, I really recommend you check out that video, it's just above, where this is a trigger word that comes up more and more often on these 2021, 2022 papers, and you'll see you get 2 marks for doing not too much work in this case. Right, and on to some similarity here. Again, this used to be a very common question on Edexcel back in the day. So in triangle ACD, B lies on AC and E lies on AD, and so BE and CD are parallel, so they're in the same proportion. What's going on here. AE is 5.2 and ED is equal to 2.6. So to work out the scale factor, so as soon as I see these, I think scale factor, well, we're going to take the whole length of the line. So we're going to take AD and then divide it by this shorter length here, AE, to work out the scale factor. Now AD is these two added together, so 5.2 plus 2.6, that's equal to 7.8, and then divided by this slightly shorter side here, which is 5.2. And again, I was going to put it in my calculator here rather than going over to the complicated looking calculator, and that gives us 1.5. Always a good sign if you're getting things like 1.5 or 2/3, things like this. And in this case, we want to work out BE, so we're going to use the 6.75 that we know, and because we're going from bigger to smaller, we are going to divide by 1.5. If I do that, so 6.75 divided by 1.5, we then get our final answer of 4.5 centimeters. Classic similarity question. Make sure you do practice those. They come up pretty often on these paper 2s and paper 4s as well. Okay, so on to part C. So again, two solids here are mathematically similar. So that's an important phrase to have here. The smaller solid has a height of 2 centimeters and the volume of 32 cubic centimeters, and the larger solid has a volume of 780 cubic centimeters, and we're looking for the height. So if I see a question like this, the first thing that comes to mind is what's the same? And notice we've got the two volumes of the two solids. So that lends me to work out the scale factor of the volume. Now, how do we do that? Well, we do big divided by small, 780 divided by 32. If we pop that into our calculator, there we are, we get 195 over 8. And we need to use this now to work out the height scale factor. You're probably thinking to yourself, okay, how does that actually differ? Well, think about what we've looked at in previous questions. So how do we go from height to volume, where we're going to cube? Remember, height is done in centimeters, volume is done in cubic centimeters. But if we want to work backwards, so going volume to height, then we need to cube root. So in order to work out the height scale factor, we are going to cube root 195 over 8. So let's go to my calculator and work it out. Okay, so we're going to use the cube root button, so make sure you've got the right button there, and then we're going to type in 195 divided by 8, giving us the scale factor of 2.899. So let's write that in, 2.899. But we actually want to work out the larger height. Now I generally write larger height to remind me what to do with this scale factor. So we're going to take that 2.899, the new height scale factor, and then we are looking for the larger, so we're going to times by 2 and not divide by it. So if you go back to the calculator once more, okay, so we'll take the answer, again using that answer trick, and then times by 2, giving us the final answer here of 5.798, like so. And again, we generally round this again to 3 significant figures, so that gives us 5.80, like so. And the last part is a kind of non-standard question here. So we've got two parallel lines, so marked on here with the arrows. P and S is a straight line, and crucially here, N is the midpoint of RQ. So with that statement there, what this basically says is that this length is the same as this length. And we need to explain given reasons why triangle PQN is congruent, so that's a really important word here, to triangle SRN. Now, there are a couple of ways you can show congruency. I'm going to take the approach of angle, side, angle. So if I can show that two angles and one side are the same, then it means it's congruent. So what does that mean? Well, first of all, we can show the sides. So Rn is equal to NQ. So they have one side in common because, and we'll write a reason in here, n is midpoint. And now we just need to show two angles are the same. And I think the easiest way of doing this is using this angle here and this angle here. These are what's called vertically opposite angles. So angle RNS is equal to angle QNP. And our reason here is because they're vertically opposite. You need to write that word in to make sure we're getting the marks here. And then we can also take a different angle. So let's take in green here. Let's go with this angle and this angle here. Notice that they make a Z. Again, we don't want to use that word in describing, but that's what I'm looking for. And so these two angles are also the same. So angle QPN is equal to angle NSR. And remember, Z angles, the proper name for that is alternate. So you need to write that in. Okay, and once we have that, then therefore the two triangles are congruent. Again, we don't need to write an essay here, but we do need to show the examiner the understanding of, I'm looking for two angles and a side being equal, therefore they are congruent, and that's the way that you can do it. Again, there's a couple other ways you can do this, but I think that's the most straightforward approach. Okay, so you can check the answers there for 11A to C, and then that last part, 11D, which is a little bit non-standard, again asking you that kind of question. Now, if you want to really test yourself and look at the hardest questions from the last year in terms of past papers, then check out the video right in front of you, because that's really going to test your mettle and whether you can get those A and A stars on your exams.